Okay, so now let's have a look at the next word problem, example 16. It's actually not that much different to example 15. The processes are still the same. So step 1, define your variables. Step 2, write your equations so you can get your simultaneous equations. Step 3, set up your matrices and set up your matrix equations of AX equals B. Step 4, solve for X. You may need to use a graphics calculator for higher order matrices. Step 5, write your conclusion with units. And step 6, check your answer. So you literally follow the same process for example 16. So I do highly recommend you to pause the video now. So try out example 16 yourself. And then you can come back and check your answers and setting out with my model answers. Yep. So example 16 says, a furniture factory makes bedroom accessories. The following table shows the time in minutes, so that's important, that's in units, minutes needed for each process for the bed heads, wardrobes, and dressing tables. So it says here, bed head needs 20 minutes of cutting, 10 minutes of hardware making, and 5 minutes of packing, etc., etc. So due to limited workers, there are only 60 hours, so be careful of units, 60 hours available for cutting, 18 hours for hardware, and 16 hours for packing. Our goal is to find the number of each item that should be produced to make full use of time. So step 1, let's define our variables. We want to work out the number of items, and we have 3 items, the bed head, the wardrobe, and the dressing table. So step 1, let X equal number of bed heads, Y equals number of wardrobes, can't spell, wardrobes, and let Z equal number of dressing tables. Okay, so next step 2 is to write our simultaneous equations. Now one of the trick of this question is not just units, because one's in minutes and the other's in hours, is also just because we're given a table, you can't just naturally assume your matrix is this 3 by 3 table with the order of numbers, right? We said before how the order makes such a difference. So you actually need to read the question to actually write your equations. You can't just assume, oh, here's a table's a matrix, therefore matrix A is just 20, 10, 5, 50, 5, 15, etc., etc. There's a bit more to it than that. Okay, so first of all, let's look at the number of hours for cutting. Well, okay, we have 2 units, minutes or hours. Choose one to convert and stick to. I find it easy to work in minutes because minutes is a smaller units. So let's work in minutes. So if we're looking at the total amount of time for cutting, well, in terms of cutting, right, it takes 20 minutes for bedhead, it takes 50 minutes for wardrobes, and 40 minutes for your dressing table. So we can write 20x, because 20 minutes per bedhead, and 50y, because 50 minutes per wardrobe, and 40 minutes per dressing tables altogether should add up to 3,600 because we're looking at minutes, right? So be careful of units. Be careful of units. We're going to convert everything to minutes. Our next equation we want to consider is the number of hours for hardware making. So hardware, looking downwards in the column of your table, it takes 10 minutes for bed, it takes 5 minutes for wardrobe, and it takes 15 minutes for dressing table. So 10x plus 5y plus 15z altogether gives us 18 hours. So 18 hours is 18 times 60, which gives us 1080 minutes. And lastly, the number of time for packing, so 5x plus 15y plus 10z is equal to 16 hours. So 16 times 60 gives us 960. So we have equations 1, 2, and 3. Next step is to put them in matrices. So let A equal, look how the x's, y's, and z's are stacked. So we can just literally write the coefficients into a 3 by 3 matrix because we have 3 unknowns. So see how I was saying before, my table is not directly the same as matrix A, right? Going down, it's not 20, 50, 40. Instead, it's 20, 10, and 5. So just because you're given a table does not imply that is the matrix itself. So just be very careful. Make sure you read the questions first. So X is my matrix, my column matrix of unknowns, and B is my column matrix of the constant values in my equation. Okay, so set up our matrix equation. So AX equals B. So A inverse AX equals A inverse B. IX equals A inverse B. X equals A inverse B. So X is equal to 20, 10, 5, 50, 5, 15, 40, 15, 10, inverse 360010809060. Let's use a graphics calculator because we cannot do that in our head. So using graphics calculator, x is equal to negative 0.7, negative 0.1, 0.5, 0.4, 0, negative 0.2, 2.2, and 0.4, and negative 1.6. Also, a recommendation is to always write your answer in terms of fractions, especially for recurring numbers. So if your A inverse ends up being like 3.333333 forever, you really should use the SD button to change it into fractions so that you get more accurate answers later on. So if you have terminating decimals, that's okay, you can write it out. But if you do have recurring numbers and decimals that go on forever, you really should be using the magic SD button, which is above the number 8 button, or between the number 8 and 7 button on top of that. The magic SD button changes from decimals to fractions, and that increases the accuracy of your answers later on. So multiplying, and also using the magic answer button, of course, because the calculator remembers the most recent answer. So therefore x, y, z using a graphics calculator gives us 24, 24, and 28. So let me shrink this because I'm out of space. Resize. So to finish off, finish with a sentence conclusion and then check your answers via substitution. So therefore x is 24, y is 24, and z is 28. So therefore we can make 24 bedheads, 24 wardrobes, and 48 dressing tables. So finish off with checking because you don't have the back of the book answers on the exam. So check. Did I label the equations? Yes, I did. So sub x equals 24, y equals 24, and z equals 28 in equation 1. So left hand side is 20 times 24 plus 50 times 24 plus 40 times 48 is 3600, which is right hand side, so we're happy. Into equation 2. So we have 10 times 24 plus 5 times 24 plus 15 times 48. Yes, it does give us 1800. 1080 using a calculator, so we're happy. And lastly, number 3, 5 times 24 plus 15 times 24 plus 10 times 48, which does add up to be 960. So we're happy. So we now know our